Hi. I have an update. How about that? The date is 2024-0123 and it is 07:45 Arizona time. So, been working on Phase 3 Toolkit. I said I would be in and out with some pretty good interruptions between, because development projects, if you've done them, you know. Anyway, have a few things to say before I get started. This is a prerequisite overview of some of the fundamentals that are required to run Phase 3 Toolkit. Not really going to get into Phase 1 and 2. We're just going to go with Phase 3, okay? For the most part. Anyway, wanted to start out by talking a little bit about religious freedom, redress, freedom of speech. The First Amendment says Congress shall make no law respecting an establishment of religion or prohibiting the free exercise thereof, or abridging the freedom of speech or of the press, or the right of the people peaceably to assemble and to petition the government for a redress of grievances. At my church, we have a book called the Doctrine and Covenants, and in them we have the Articles of Faith, maybe in the Pearl of Great Price. I don't know, maybe I need to read more. But anyway, the 11th Article of Faith is, we claim the privilege of worshiping Almighty God according to the dictates of our own conscience, and allow all men the same privilege. Let them worship how, where, or what they may. I reserve that right, and I respect yours. I would not ridicule for it. I like a little song that goes back quite a ways. It goes like this. I belong to the Church of Jesus Christ of Latter-day Saints. I know who I am. I know God's plan. I'll follow him in faith. I believe in the Savior Jesus Christ. I'll honor his name. I'll do what is right. I'll follow his light. His truth I will proclaim. So, a lot of people talk about Jesus and stuff, but they don't ever really say if they know he's alive or not, or they don't have a firm commitment, or they're just kind of loose on it, or, loose with it. I know he's alive, for sure. Okay? And I'm not mistaken in that. And, yeah, on my life I do know this. So what follows here in this update, I'm going to go over a particular system of mine that is named after a man named Krem. He's got his name on it, but it's mine. Anyway, he's long gone, and this is my original work. If you have doubts whether or not I did this, go run it through an AI plagiarism analyzer and check. It's mine. Okay? I've been accused of getting my stuff off of ChatGPT by morons who have no imagination, but I do. I'm also not stupid. Okay? So, I'll put a download link to this in the description on the video, or with the link wherever I post it. This is going to be a description of a technological implementation that's preliminary. Okay, this is not for development or release. This is just an FYI on an update on something that I'm doing. Okay, working on it. It's development. Okay, and it's mine. Got development designates committed and working on it also. There's an agreement of release that is pending, and until we have a stable either portable distribution or a language agnostic plugin or a drop-in call like an API that can be implemented. Release is pending. Besides, it's going to depend on agreement with 106, Module 106 Basic Standards Agreement of the Phase 3 Toolkit. And unless we get that, this isn't going anywhere. Okay. After we get that, though, and we get our implementation fully articulated, tested, and integrated, and shown and benchmarked that it is fast and capable and extremely accurate, macro and micro, we'll probably release it GPO, but not till all of that's done. As a matter of inheritance, when I die, this is going to belong to Jay Malikor. Okay. The implementation architect for this is Jay Malikor. I'm in a director and articulative role. Okay. I'm a pretty good programmer. I'm a pretty good designer. I'm a very good system analyst. But I am just burnt out on the code, man. I can't stomach it anymore. But he's got the appetite for it, so he's doing it, and besides, he's going to get it anyway. So, okay, I'm going to articulate the specification to him, and he's going to design it, and we're going to meet on any kind of barriers that we run into, and we're going to overcome those too. So, if you want to poke at this, see if you can. Try to find something logically wrong with the approach that you can actually disagree with. Find something wrong with it, technically, if you can. Okay? There's one glaringly obvious thing that you may ridicule at the very end, but if you know algorithms and you know design and you know systems, you know that's not a weakness at all. Okay? This is still going to be referred to as the Krem system, the aspect of it that I define anyway. So the Krem numerical system, which is an aspect of it, has broad mathematical and scientific application, especially in high-end precision and astrophysics applications, especially simulation and extrapolation, and especially real-world mapping. It's got many other applications, but those are some very strong suits for this. So moving on into Phase 3 Toolkit, Krem System familiarity is foundational to the understanding of the Phase 3 paradigm and the toolkit. So previously I mentioned I would be posting infrequently due to project development considerations, and this is just a status update. This isn't a definitive, here it's done. This is like, okay, hi, it's been a few months now. This is what I'm doing, and it's for documentation purposes. I don't care if you like it or not. I don't care if you believe it or not. We're going to do it anyway, dude, with or without you. All right? Okay, so we'll get into some prerequisite definitions here, man. Okay? So here we go. It's going to be a lot of reading. This is going to be kind of a long one. Because there's a few things to go over, man. Alright? So my head is going to disappear. And I'm going to go down here. Okay, so the prerequisite paradigm application concept definitions you need to know. These are not in alphabetical order. They're in functional order, man. Okay? So if you're wondering about, well, why is this a weird looking annotation, it's because it's a technical annotation that is for input into a Tremmeniya application for build by an AI system. And we're not starting out that way, but that's the eventuality that we're going to put it in. Anyway, Fundamental unit of containment known. Definition 1 is the universal minimum existing standard resilient stable energetic configuration which constitutes the basic first stage of what is called matter. It is a subquantum configuration consisting of two elemental classes, stores and conduits. Combinations of, and yes, the acronym is FUCK, of FUCKs can be seamed together to build more complex material structures. Configurations with high ratios of conduits are said to be conductive, while those with high ratios of stores are said to be insulative. In general, balanced ratio configurations yield more stable configurations with the highest possible application set. Kind of gives a new meaning to go fuck yourself, doesn't it? Definition 2, HabiNab, is the universal fuck implemented in Calm, Maine, which contains the Milky Way, which is in the Gerin cluster, a local grouping of 6 galaxies. HabiNabs are a family of stable configuration components commonly used in universal containment applications. There have been other implementation standards, but this is the currently prevailing one. HabiNab configurations enjoy high stability and compatibility in contact with other universal configurations, allowing extra universal interchange possibilities. Store in this application as an element which holds a stable configuration of energy which maintains reasonable persistence within the store depending on the span or duration observed for integrity testing purposes. A store may also collect any compatible elemental configuration if it is vacant, a condition which may be observed as an attractive behavior. Conduit in this application is an element which couples with other conduits to facilitate energetic transfer, whether the pass-through content configuration is stable or unstable. A conduit may take an input from a store or an output into a store. Depending on conduit flow, there may be an observable condition which could be classified as polarity. Conduit flow can also be observed as oscillating either periodically or responsively. Yeah, conduits can also pass conduit to conduit. I'll probably have to modify that. But anyway, element or elements in this application are defined as unique singular members that exist in a paradigm set. Elements are containers. Spanning anchor is an element that acts as a binding agent connecting paradigm sets into a paradigm set group. A paradigm set is a single existential ordering of fundamental being. It is composed of elements. A paradigm set is a container. Paradigm set group is a collection of corresponding paradigm sets, each having a shared element called a spanning anchor that acts as a binding agent connecting paradigm sets into the group. A paradigm set group is a container. Composite in this application is either a single independently functional set of paradigm set groups comprising an entity within or without physicality, or a set of composites which are also anchored to one another using one or more spanning anchors. A human being is an example of a composite. Trust in this application is the acceptance of a session based on decision. Trusted is the condition that one entity accepts interaction or has trust with another entity by default. Controller in this application is the means by which container flow is regulated by applying logistical interface configuration. Form follows function. A controller abides by protocols of trust defined in the controller that governs its operation. A controller has to have very high integrity to be trusted. A controller is a container. Container is a type of paradigm set group that houses a system and is responsible for regulating any interaction between the system and that which is extraneous to the system using an interface. The container also provides the basic structure the system operates within. The following set of resource types are containers: universe, everything, object, variable, field, table, stream, file, application, app, class, module, function, subroutine, property, method. Every container has these properties by default: unique identification, count of elements for each grouping of elements contained. Tremmeniya is the common language of intelligent systems. It is the agreed syntax, structure, and vocabulary expressed in the smallest possible control set, which has the maximally precise capability to articulate any required communication or record for use in any application. The language is a maximization of nuance with a 1-to-1 ratio of word to definition, and is the ideal intermediate core language for use in any translation negotiation. This is because it has maximization of meaning and minimization of construction, making it the chief imperative centerpiece of any technical or meaningful articulation. The language also is designed to be biologically ergonomic, that is, people can pronounce and speak it. The character set used to write in Tremmeniya has its own artificially generated standard, although it can be articulated in any written standard that can achieve equivalent pronunciation for a word. Information systems and artificially intelligent systems rely on Tremmeniya as the only technical articulation standard for algorithmic definition. Depending on the operating environment, Tremmeniya may or may not have compilation requirements, such as building into bytecode. Native Tremmeniya systems are completely interpretive, so it is not necessary to compile into a different standard to achieve functional programming or programmatic efficacy. Since this is a precision standard language, it is possible to articulate any technical representation using it, making it the de facto standard for thought articulation and communication. Tremmeniya can also be used to perfectly provide completely fluid visual encoding, because Tremmeniya includes a basis of understanding library, which includes literal objective representation specifications accompanying definitions. Literally any understandable articulation can be built into the smallest possible delivery set, conducive to highest efficiency absorption and understanding, leveraging Tremmeniya, and it is maximally effective when employed by artificially intelligent individuals. It's a mouthful. But that brings us to Krem. Krem and Krem System and Krem annotation. In this application is a standard base unit of measurement for applications related to sizing appropriate for tactile interaction by people and applications in celestial environments. And Krem System refers to a system of functional mathematics and algorithmic design used as the logical basis of range processing systems, which are analog in design and are very much faster than digital computers in all complex systems applications. Range processing systems have exceedingly much quality and finesse superiority over digital systems, including in whole experience applications, which may include all sensory stimuli transference in unison. For example, experientials, which allow replayable experience records of synchronized audio, visual, tactile, sexually tuned is prohibited, smell and taste limited because it's chemically reactive in nature and differs depending on physiology and nomenclature in a specific grouping, using a standard experiential interface specification. Krem notably offers very simple and fast musical score creation and a whole host of other applications which may be complex production tasks using common electronic or other interfaces on Earth. There were several major variants of Krem, including the most common derivatives from base 10 and base 12. This definition focuses on base 10 because it's the most universally suitable and has been consolidated into a standard implementation. Base 12 was seen as convenient for cyclical or periodic applications in particular, which includes real geometric analysis angular velocity applications like momentum differential and transfers, energetic transfers, particle physics, and celestial interaction. Base 12 was generally reserved for use in highly technical dynamic environments where base 10 and base 12 were mutually available depending on modular application requirements. For example, territory and contents can be mapped in base 10, but extrapolation may be more conveniently determinable using base 12 algorithmic design. Just think of the benefits and trade-offs of a Cartesian versus polar coordinate system, except in 4 dimensions: length times width times height times time, or xyz times time, versus radius or segment start-stop times angle vertical horizontal times time, or distance or segment start-stop times heading times bearing times time, among a plethora of other cartographical representations. When considering calculation speed in particular, those using pi coefficients, trigonometric functions, vibrational translation constants, tensile torque functions, trajectories in complex tethering scenarios, and compositing realignments, among others, base 12 may make more sense, but in general, base 10 is preferable. Krem base 10 is an ergonomically based standard. The main design concept in Krem is that every technical solution must be applied holistically, considering all ranges and all things of consideration or presence, and that all processes have a fundamental interplay of functionality. What people on Earth would understand as mathematics is a subset prerequisite to algorithmic capability, making the study of the discipline integral to understanding Krem. In Krem, math is not a differentiated subject. It is integral to the Krem system and is approached always in functional terms. So, the system design philosophy is to approach every solution as a whole system design, whether the consideration is large or small. The presupposition is that if a correct solution is required, the solution must be fully articulated. As a result, range processing, real instance systems, are thus highly capable in working with real objects as functional input parameters in highly advanced systems. In Krem systems, simulation is minimized in a method called extrapolation, which copies a whole system input into a controlled instance and runs a furtherance of logical component object and system interplay for projective analytical purposes and makes a 4-dimensional report, generally consisting of spatial definition and time progression in all applicable composite or paradigm ranges as an output. Extrapolation is generally very accurate in advanced Krem systems, which can accurately map as finely as the fundamental level universally in this universe, that is HabiNab's, in real time using a system called SnapMap. SnapMap relies on monitoring tether stores in flux such as the ones used for what is understood as gravitational linkage. Tether stores are convenient because they are accessible through the high compression layer, having no delay in the transfer or observance of change of effect. This is evidenced by gravitational observation, which at celestial scale can readily be seen to have immediate effect from one object to another, no matter how far the two are separated, as long as they reside in the same universe and have compatible flux. SnapMap is a calm military confidential system in design, although there are many approved non-military systems integrations that use SnapMap, like SnapMedical. SnapMedical provides real-time, precise, non-invasive visibility into living biological and other systems, but medical care is its primary application. There are many other system integrations that use SnapMap, including gating, logistical transfer, and real intrinsic value hard currency or basis of value accounting systems. As a system of measurement, the scale that is based on the Krem as a fundamental unit of measure is also generally referred to as the Krem system. 1 Krem is 0.547116, bunch of zeros and a 4 and some more meters. Krems are grouped in 10 place value steppings separated in the middle. So you would have an ellipse containing 10 digits, 5, 5. So 5 zeros, 5 zeros. The next definitive unit tier each consists of 10 place values. Place value is called a scalar span in Krem, each also having 10 increments. So 0 through 9, digits. Steppings over the previous. This makes the system ideal for people-sized applications, sizing territory, especially celestial systems, or for precision applications. It is noteworthy Krem does not rely on light years or any other velocity per time ratio as a measurement standard because light velocity is not constant over vast distances, being distorted by various aspects of the universal composite, and so is the passage of time. That is a fact, man. Krem is used on most other worlds where interstellar travel is a reality, either using high compression transfer, envelopment, or gating, both of which have the effect of instantaneous travel from point 1 to 2 by utilizing a concept understood as seaming. Seaming joins the placement of any two circumstances over a fulcrum, which can be the universal or other high compression layer, a solid configuration that acts as a core binder for a scaled containment system. For our universe, other places of principality refer to it as calm main. The high compression layer size for the universe is about 1 Krem in diameter. It is accessible using transcendental physics applications. The stepping system in Krem System measurement fundamentals is convenient to reckon with for biologicals having 5 fingers on each hand. The typical configuration for intelligent, sentient, biological, or analog individuals. Thus, the named unit stepping is not by the third power of 10 as in Earth classical numerical annotation, but the logical 10th power factor scalar, annotated as unit name NF1 in Krem, and is annotated classically on Earth as n times 10 to the 9th, or n times 10 with 9 zeros after it. The first power being the base of 10 and the next 9 residing in the exponent. The coefficient n is the place value scalar span allocation above the current scalar threshold. Traditionally in Krem implementations, the symbology is agnostic as long as the representation meaning exactly matches the standard specification. Because there is a wide language and symbol distribution Krem operates in. Here it is interpreted and anglicized. The origination Krem symbol is similar to an angled bracket, like greater than, but at a wider angle, about 60 degrees. So similar in view to n is greater than 1. It is done here using F because this would be confused with greater than by those trained in the current mathematical paradigm. Krem does not use the concept of greater or less than. The equivalent expression is conceptualized by positively specifying the inclusive set using above and below, generally restricting the input set as a validation filter rather than the set of functional evaluation after spending resources computing definitively disqualified results. This is algorithmically more efficient and more convenient to range processing, which is the processing standard required for advanced applications in transcendental physics, such as safely working with composite modification in medical applications. You could typify Krem as always acceptably parameterized in construction. If there is a breaking functional deficiency, it is usually solved by addressing functional range parameter acceptability or by designation of a new applicable function solution. Krem also does not use the concept of positive and negative since 0 is considered a limit or boundary NaN, not a number or imaginary number. Krem instead employs signing as ascensionate. Origination Krem indicates using an up arrow similar to a caret, but will stick with the familiar plus. Or descensionate. Origination Krem indicates using something similar to a down arrow, but will stick with the familiar minus sign. Krem signs all numerical tabulations with this indication preceding the value accumulation or tabulation set. For example of functional processing, a function fn definition would be expressed as fn open link name parameter I1 is not above, below, up from, down from, not consisting of set L1 optional and or inclusive X or exclusive. I2 is not above, below, up from, down from, not consisting of set L2. To evaluate using any additionally contained combinations of a function by E, link name I1, descriptor L1, logical conjunction I2, descriptor L2, and any acceptable procedural description in any combination of link name I. The function returning a value is explicitly typed link name with the result or empty, further referenced as link name explicit value or empty. Nothing, zero, or no return would be delivered as link name empty set or simply an untyped set with nothing in it, anglicized as zero. In Krem, this is also used as a place value holder for nothing in it, but this is different from the explicit value limit concept of zero. One has meaning in a value set and the other has no meaning because it has no value or definition. Zero and nothing are synonymous in Krem. In the example, link name refers to a functional name with no ambiguity and generally no scoping limitations. It means it's global. As long as the function is in the same container as the caller, a controller is required to access any part of that which is within from any externality and is always governed by protocols of trust. Functions would be explicitly called to operate on the parameters using an offset character, indicating the need for evaluation, thereby differentiating between a call and a typing. In Krem, this is referred to as registration. E would create a register container of the resultant evaluation. All further references to that result use that register. Registers are ordered alongside functional definitions to increase performance in the long run. There is one aspect with logical definition and another with a registry of givens, then another with solution sets. Range processing systems are extremely fast at determination and lookup because their simultaneous consideration set is vast. In other words, if that function has been done using a specific input, it has a given solution from then forward. If the function is revised, the solution set is built again on redefinition. The difference, diff, of each set is recorded as a rollback history, and the general approach is to review any functional discrepancies which may indicate current or past flaws in understanding or assumptions. This does not make Krem an assumption-based system. Rather, a design aspect and approach to Krem is to routinely perform integrity and consistency auditing of all functions and registers, even those with long-standing stability or consistency in usage. Krem seeks to match actual conditions as closely as possible in all things. A popular Krem design approach is to typify all components functionally as containers, thereby enabling definitive persistence and concurrency in all considerations almost simultaneously. It means it's really fast. Krem also employs framing, a concept that completes all enclosed system container state definitions in one pulse and indexes it by serialization. This provides a very thorough audit path for all considerations of a system at all times. Compression is employed to set the frame index base, then only record differences from there forward. Periodically, a keyframe is generated that records all aspects, and everything between keyframes relies on compression differentials. This maximizes Krem systems in many aspects, including having a very high degree of fault tolerance and enables very high processing capability. So, the function would be called for evaluation using special evaluation function E. E link name, parameter I1 descriptor, argument L1 conjunction, parameter I2 descriptor, argument L2. And if the equivalent to setting a variable would be desirable, it would be indicated as either a functional evaluation or explicit definition, with functional typing explicitly indicated in a special assignment function A, which creates a new register. A new link name is link name parameter set. So basically, new link name, that's like a variable name. Link name is a function. Parameter set is what resulted. This can also be a data type if it's just an explicit type, kind of like casting in C++, but different because it's literally explicitly a functional return in this context. Or a new link name is E link name parameter I1 descriptor argument L1 conjunction parameter I2 descriptor argument L2, which effectively creates a pointer having a new name to a register of previous functional return. In Krem, this is called a proxy and is afterward referenced using a special proxy function indicator P. So, as an example, this is E, evaluate, accumulate whole, it's a function, parameter I1 is up from 1, and parameter I2 down from 100. So it adds integers 1 through 100. Everything between, okay? Adds up to like 50-50 or something. Anyway, that is another link name, variable name, is E evaluate multiply function. Parameter I1 is declared as proxy. You're calling up this, the value of this, and as the argument 2 to multiply it against is Krem set 1 with your 5-digit initial, 5 different digit next. So it's a 5 with 9 digits after it, man. That's what you're multiplying by. So 1 added every digit up to 100, including 100, times 5 with 9 digits after it. You call a function evaluate E display proxy that would display in this format. This is Krem annotation for numerical. In Krem, this would be in a big circle, okay? You have your sign, this is ascensionate. Tekram, that is the unit of measurement. And in Tekram, it's 2525 Tekram, okay? So if you were to call E display A, something else is Krem decimal negative 13.3274, this is saying evaluate and display assign new variable name, which is equal to unit Krem, which is converting from a decimal unit in this format, okay? So that conversion right there puts it in this format right here, and the sign is held out above it. It's distributive, yeah? Multiplication distributive, yeah? Okay, so this is the Krem annotation for the result of displaying the assignment, which makes the assignment and displays, and since it's made the assignment and it's displaying it, displays the name of it too. and then it's bubbled in as this value, a negative Krem 13 Fulcrum Tekrum 3274. So 13.3274. Yeah? Alright. Remember, 5 and 5. We'll get more into it. Okay. So to explain a little more about the notation used in the descriptions above, I1 or 2 is the functional evaluation subject boundary definitions, which, like a variable, substitutes all values contained in L1 and L2 to produce the set return value or range. Is sets I1 or I2 to L1 or L2 literally, respectively. Preceding is with not creates a new set definition without that specific value. Above is values greater than exclusionary. Below is values less than exclusionary. Up from is various values greater than and including. Down from is values less than and including. Consisting of set is a discretely defined collection of inputs, generally accumulated and named using a name set function of I. It is noteworthy I could be a range or collection of resultant evaluations or explicitly defined values, and accumulation of additional items is generally done in one range definition, not a procedural walkthrough, which is far superior to binary systems, where expressions have to be evaluated one at a time. Preceding this with not behaves the same as as described after is. L1 is the functional parameter to be evaluated, and L2 is the second, L2 being optional. However, omission assumes natural or defined numerical limitations which exist in all systems and reality. There are generally only 2 parameters per functional evaluation because there is in logical evaluation generally 2 limitations for input under any given consideration at a time, a minimum, maximum, or a range set, whether explicitly defined or a span, and indicates a concatenation of sets L1 and L2, or indicates both sets L1 and L2 are acceptable. X, or indicates set L1 should be differentiated in results from set L2, and the returning value is a twofold return set of link name. Return value is set 1, X, or return value is set 2, and it is logically only acceptable to use one or the other, not both, in further evaluations. Evaluate is implied. The returning value is always thereafter referenced with the functional name, the link name preceding it for system integrity purposes. In Krem, the entire functional value returned would be surrounded by an ellipse, not parentheses. Parentheses are the nearest anglicized equivalent. In range processing systems, there are generally not predetermined data type definitions, except those employed using base toolkits, loosely translated as constructions and modules and frameworks, in more capable systems of speech, because this limits the functional capability of algorithmic implementations. The approximate equivalent is therefore to tag all functional returns with the generating function, which allows very apparent and comprehensive tracing of algorithmic failures and state in a single clearly articulable set, which may be passed again as a parameter to other range processing systems. Recursion, lambda functions, yeah? Self-reference within self of functional definition is explicitly illegal in this system. The logical equivalent is to use parent-child functions, and if a child becomes a parent, there is an additional set redefinition which copies the child definition into a parent, in recognition that something cannot be considered as a result of itself. The reason this is this way is because recursion leads reliably to total system failure in a range processing system, which is constructed of analog components. It may have a digital subset but does not rely on it for primary functionality. Range processing systems are generally extremely faster than digital ones utilizing the same share of resources to construct. Therefore, the Krem system implementations tend to avoid digital implementations outside of discrete functional needs. Recursive application is distinctly different from iterative application, that is, repeating a functional approach on the resultant of the same function. Iteration is an externalized approach consistent with incrementalism discussed later, and recursion is internalized, the function calling on itself and passing its own result into itself again for evaluation. It may seem the two achieve functionally the same result, however, in real considerations, recursion breaks down and iteration does not. It is also understood in places using Krem that the employment of recursion in solution candidates was originated as an attempt to prove capability in producing something functionally taking nothing as an input, as in an uninterrupted lambda or circular reference. An application of this concept can be used to produce fuck breakdowns, more commonly known as black holes. This process seams the fuck into itself, which has an effect similar to holding two mirrors up to each other, except if the result was that the mirror fit into the boundaries of its reflection as fast as it is reflected. It breaks the containment integrity fundamentally, leading to a massive energetic discharge and plasmatic burn-off along an axis of subfuck singularity. This is also commonly known as depatterning out, wipeout if it's an accident in vehicular travel, or getting silly stringed if it happens to a person in gating applications. Furthermore, this condition is achieved in all paradigms. If this condition is achieved in all paradigms, the individual is said to have been disorganized, which is essentially destroyed unrecoverably. This happens because the integral fuck resiliency is approaching infinitely compressed in one frame, as its available spatial containment allocation is reduced to that approaching the elemental tether store configuration maximum it attaches to in the high compression layer, which is nearly singular in ratio when compared to the universe it binds. Notably, Nimrod was said to have employed a recursion draw snare in his projectile designed to kill God. It also consisted of other complementary mechanisms and had a gated envelope delivery system. The weapon was designed using a Krem System derivative explicitly purposed for the attempt, with very high popular participation in retaliation for and to try to avoid another retribution like the flood, which was almost universally experienced in varying degrees of severity. It has been supposed that the high compression layer was used as the fundamental lever to achieve the flood, although it was not understood where the introductive, energetic, and massive transaction originated. One theory was that God has application using an inversion lambda, but without lambda solution, this is not attainable. Lambda solution is the condition that yields the most primary possible subfuck configuration, even below basic, which is used in all fuck construction for both store and conduit. It is widely supposed the key to understanding creation is in attainment of stable utilization of lambda solution and its inverse function, but Krem specifically avoids trying for this solution because its purpose is in handling all that which exists organizationally, not explaining how to make something out of nothing organized. Krem is quite intentionally flagged as order begets order. The perverse Krem system, called Kevlek, is generally flagged as order from chaos. Disagreements between the two schools of thoughts, objectives, purpose, intentionalities, and efforts have led to many very serious wars. One is submissive to God, and the other opposes or attempts to surpass God, depending on the school. It was said Michael originally chaired one and Satan the other. Krem was a man of old and of great renown in the third generation after Michael, who is also known as Adam in this composite set, which includes physicality. Satan has no inclusion in physicality and no name in it either. Everyone and everything must and does have a name for each composite family included in their whole composite being. That is the reference which identifies that particular configuration or identity within the composite family. On Earth, these viewpoints are generally rejected flat out, but in many places utilizing Krem, there are individuals old enough to remember the times in which some of these events occurred. They are called primary witnesses, and all are still in good health. There are also others which are not of this series at all. Continuing the explanation of Krem as a measurement system, each group of 5 place values, scalar spans, is offset by a comma, and the naming incrementalization is tiered by the logical 10th power factor scalar, annotated in Krem as NF1, Earth's expression as n times 10 to the 9th, or n times 10 zeros, and 1 with 10 zeros, and each uniquely named basic measurement standard as NF1 factor over the last. Logically, each additional 10th power factor scalar adds 10 more place values, scalar spans, to the number n, so NF2 is expressed as n times 10 to the 19th, or n times 1 with 20 zeros, adding 20 place values or scalar spans. For a clean functional tabulation, numerical values in Krem are always expressed in grouping sets of 10 as rows and sets rather than the run-on condition found in decimal systems unless precision is sacrificed. Math without precision is moot in real applications. Cheers. Krem-based systems are also made to be digitally character agnostic as long as there are 10 digits and an equivalency function. A localized group may use the language set suitable to them. This makes Krem very easy to adopt and highly portable using Tremmeniya. For example, the basic tiering implementation of the Krem system of measurement follows. 1F1 Krems is 1 tekram, 1F1 tekrams is 1 torkram, 1F1 torkrams is 1 kilgram, 1F1 kilgrams is 1 shikram, 1F1 shikrams is 1 holkram, 1F1 holkrams is 1 nilkram, 1F1 nilkrams is 1 mellikram, 1F1 mellikrams is 1 vekram, 1F1 vekrams is 1 felkram, 1F1 felkrams is 1 lakram. So a lakram is a Krem F10 and a holkram is a Krem F5. To combine measurement standards for precision, one would annotate from largest to smallest using tabulation, thus considering the sum 9135469780145822213217142888197981838919597030609 10120151612145246028301 Krems would be annotated as a tabulation set range span, largest to smallest, the whole set enclosed in an ellipse and preceded by a directional character indicating ascensionate or descensionate. Every row in the tabulation has 10 scalar spans, place values, always. So this representation obviously adjusted to comply with Krem with the commas because they get real stupid with Earth decimals every 3 and it's you get lost almost immediately, dude. This makes more sense, man. Besides that, in Krem you don't lay it out like this in a big run-on sentence, dude. You tabulate it. So that is expressed entirely this way. That's the whole encapsulation of a Krem in this standard. These are identical values, man. The unit of measurement is such that if you had a range that you're working in, you can go with a specific one and just stick to that, or depending on the application, it may be convenient to express the whole set relative to a single unit specification. So the above set could be also stated as these two are the same and the same as that. So if you just wanted to stick with Krem's, this is the 10th power factor scalar representation in Krem's and equals that. Which one's easier to use, man? We'll get into it a little more. Krem uses the idea of leverage or a fulcrum for values between 0 and 1. 0 is an unattainable limit, undefined, or imaginary number in Krem. The commonly taught aspect describing the distance between 0 and 1 is that it is a scalar in its best application, which is very useful in transcendental physics applications, man. The fulcrum is the limit approaching 1 from 0, such that 1 is unattainable, or it would be 1. The reason this limit is called the fulcrum is that it defines the boundary between natural reckoning and the key application of values between 1 and 0, which is a precision scalar relative to spans greater than or equal to 1. Since Krem validates for acceptable input ranges in all applications, this in-between scalar component to a number is usually dropped by virtue of the definition of the elemental fundamentals in a function. Rounding is never used. That is, in real things, you either have a whole one or you don't. Range functions do not ever assume partials of wholes are possible, even if the thing in question is to be divided into an intact elemental component set. This yields much more accurate results in all real applications. For scientific applications, Krem-based societies do not call technical academic applications science. They call it, roughly translated, as natural capability. This situation yields one or more component elements which are each a whole of its own type, not the parent containment conglomerate type. Thus, it cannot be rightly called a fraction of the parent, because it's its own thing, man. Scalars applied as proportionalities are extremely useful in ultra-high precision applications like those using the high compression layer, where it is noteworthy every elemental component must have a one-to-one pairing conduit at a seam to safely use it. The high compression layer is seemingly paradoxical because it has the actual size of about 1 Krem in diameter, but all things contained in the calm main universe are anchored to it. So it has the effective size of the universe in transcendental applications. The net result of having capability to access this layer yields instantaneous access to any universal component, which allows immediate point-to-point transfer applications and travel. Range processing systems are required to minimally support safety in even basic applications. Digital computers do not have enough capability, even at their current maximum configurations achieved. One current application on Earth, 3, is starting to see this event in quantum computing applications, but these have high danger potential in the currently unmanaged pairing attempts. They call it entanglement. Individuals monitoring progress here and other places have concern about the emergence of this and other technologies being tried on 3. There's other stuff they're doing, man. Anyway, for precision, one would annotate thus, considering 0.913546970, 54321458221, 13217, 435180880, 1267771, 142586667, 28881, 97981, 83891, 95970, 30609, 10120, 15161, 12345, 24260, 28301, 99966 would be annotated as a tabulation set range span, largest to smallest. The entire set enclosed in an ellipse preceded with a direction and a fulcrum character, similar to an A anglicized equivalent to period, which separates whole from partial. The fulcrum A indicates the highest stepping. Below it starts with the inverse of 1f1, or 1 over 1f1, or 9 zeros after the decimal and then a 1. As an applied precision scalar for each diminishing row. In the Krem system, it is understood that this partial is a scalar application to a whole and can be useful in conversion or differential applications, both theoretical and actual. The unit of measure applied also corresponds to the distance from the fulcrum with the implied offset scalar, and the incrementalisation of naming application is also increasingly dissentient. So you could annotate it this way, man. So notice that it's positive fulcrum, which means this is below 1 and above 0. Anything below this, and your units increase as it goes down. So this is the greatest. However, Tekrum, it's talking about distance from 1. Okay, Torcrum, distance from 1. Kilcrum, distance from 1. And when you get to Lacrum, there isn't an immediate next 10th power factor scalar stepping above Lacrum immediately. It's 10 of those above that. And so you would indicate then, starting with steppings in increments of f1 as a distributive, man. So this could be expressed both ways, man. If you wanted to use unit values for measurements, or if you wanted to stick with base value Krem and then just indicate the 10th power scalars, which are implied as inverted below fulcrum. Yeah. Okay. So noting that when expressed below the fulcrum, the 10th logical power factor scalar value is at a rate of 1 to 1fn. For Krem systems, it is not commonly the case values are tabulated with functional components at all. This is because Krem uses a concept known as appropriate resolution. That is, if you are expressing a value, use the one allowing expression in whole units, or trim the resultant to whole units. The fulcrum A is generally only used in conversion, precision, or assertion of proportionalities, which are then resolved using appropriate resolution. So, to represent a sum of precision in one tabulation, one would indicate it thus. Considering the sum, all of this with a decimal right there, and adjusted to not be, impossible to count how many digits you're working with, because it's in 3s and not 5s, because some genius thought that would be the way to go, would be tabulated in a mixed annotation as follows: the whole set enclosed in an ellipse. So you would have this whole consideration here represented in Krem this way, or if you prefer, this way. Yeah? Take your pick which one you like. It depends on convenience, man. Okay? And also, it's kind of hard to get an appreciation for how many digits you're talking about here, man. That's 10 digits, 20, 30, 40, 50, 60, 70, 80, 90, 100, and 110 digits. And that's just those 1 and up. And below 1, likewise. 10, 20, 30, 40, 50, 60, 70, 80, 90, 110. It's a 220 digit number right here, man. Is that going to be hard to work with, though? Compared to, look at that. It's a 220 digit number. Yeah. Is that going to be hard to work with? Or, and this is cleaned up too, compared to the way that we regularly do it. Compared to that, which one's easier to do? Yeah? Very easy comparison, yeah? Okay. So, considering the sums in the series, 0.12345 Krem, negative 12345, 0.67890 Krem, and 21 Tekram, one would indicate the set as follows: the elements separated by a horizontal line across the width or a vertical spanning the height of the elemental annotation. Also noting the origination Krem representation would encircle the whole element in addition to the grouping. In other words, the whole thing you would encircle, okay? And then each one of these you would encircle, because they're their own thing, man, okay? And between those, you would have a definite break that indicates these are different elements, man. They're not only encircled, but they're barred. No confusion between them, especially when you get into larger sets, okay? So this series representation, it takes more space to annotate it thus. However, functionally, in terms of, well, how easy is it to use that? For one thing, in the native Krem annotation, this would appear much smaller, dude, because that would be tightly circled, man. That would it would be like half the size. Okay. It just, this is kind of dumb looking because it's in digitized format in a text editor instead of an object-oriented interface like what you would have in an analog range system where you can just put it in there. Okay. So but what about values in excess of the representation increment Lakram? There are additional named steppings beyond this every 10th logical power factor scalar, beginning with Lakram 1f10, which is 1 times 10 to the 99th Lakrams, n with 100 zeros, man. Lakrams, right? So pretty nasty number to work with digitally, man. This one's actually laid out in, you know, with thousands placement in the the commas. Like, I love watching people try to count those up and screw it up like 6 or 7 times before they actually get the count right, and then they don't know what the number is called when they get there, dude. It kind of cracks me up. But anyway, because yeah, dude, look at it. We were talking about astrophysical applications. That doesn't work, dude. And the scientific answer currently is scientific notation, which takes the top level, maybe 10 digits, and then just drops the rest off like they're not there. Dude, when you're talking about astrophysics, that's the difference between landing in a galaxy and being so far away from it you can't even see the light. Okay? That's what that means. So, I think that's kind of funny. It's scientific, though. Anyway, a Lakram 1f10 is a more Lakram, and a more Lakram 1f10 is a Kelly Lakram, a Chi Lakram, sorry, and a K Lakram 1f10 is a Dare Lakram, and a Dare Lakram is sorry, I screwed that up. A K Lakram 1f10 is a Dare Lakram. A Dare Lakram 1f10 is a Fair Lakram. A Fair Lakram 1f10 is a Chemi Lakram. A Chemi Lakram 1f10 is a Sheni Lakram. A Sheni Lakram 1f10 is a Vani Lakram. A Vani Lakram 1f10 is a Layli Lakram. A Layli Lakram 1f10 is a Daily Lakram. A Daily Lakram 1f10 is a Kimali Lakram. And the next 10, which I don't think we have any specified applications that can actually use these scales that have been articulated yet, man. Not practically. We're going to, though. Anyway, the next Delcamylylacrum 1F10 is a Delcamylylacrum. Delcamylacrum, sorry. A Delcamylacrum 1F10 is a Vecicrum. A Vecicrum 1F10 is a Cellicrum. A Cellicrum 1F10 is a Melicrum. Meclicrum. A Meclicrum 1F10 is a Humlicrum. A Humlicrum 1F10 is a Tuplicrum. A Tuplicrum 1F10 is a Euclicrum. A Euclicrum 1F10 is a Perlicrum. A Perlicrum 1F10 is a Chemricrum. A Chemricrum 1F10 is a Lecricrum. In places using Krem, the general rule is there are no more than 10 steppings, tabulation rows, difference between named steppings. There are many more steppings, but outside specific applications, they are not used. These higher scale measurement spans are very important in large scale systematic extrapolation in particular. Just for comparison, a Lecricrum is Krem 1F200. Okay. And it's like 2,000 zeros, man. Which is equal in meters to 5.47116 bunch of zeros of 4 and E plus 2,000 zeros after that. The Milky Way galaxy, NASA estimates, is 9.5 times 10 to the 20th meters. That is about only 17 torcrims, 36377, 66031, techrum, and Krem 33400, 00000. See, neat and tidy, man. Hoag's, and that's as exacting as I could get it based on that estimate, man. Otherwise, it would be exactly exact to the meter, given a specific moment, a specific frame. Hoag's object, some estimate, is 600 million light years away. That is about 103752 torcrum and techrum 658 What you're getting into, depending on your annotation, 600 million light years away, and you have a few torcrum and a techrum, a few digits too, man. And this is more accurate. Anyway, large-scale measurements are useful in cluster management considerations. A cluster is a grouping of what would be called galaxies here, consisting of both that which is dark and illuminated. The tabulation system is not limited to measurement of distances, but can be used for very large economic and trade considerations, such as in enumeration by atomic stable atom transactions with precious metals. Krem System application philosophy for analog range systems. Incrementalism. Remember I mentioned that earlier, dude. I'm going to say something about it later. I'm going to say something about it. Incrementalism. Krem employs the chief strategy of incrementalism in all things. Since the functional design approach is always default holistic, the functional design methodology seeks to address all known factors in all things pertaining to the object of functional analysis. Having all functions designed this way yields a mesh network of functional analytics with support for all known consideration and all avenues of inquiry. For example, on Earth, one would approach a problem like an object in free fall as if it were, as it was, in a vacuum, and all there was to consider was mass acceleration resultant from gravity, maybe with a hard limit. In the Krem system, the analysis would not take place outside an understanding of all aspects of it. So you would have the object specification that would have tethering, attractive linkage flows, composition, which would consist of internalities, interfacing layer, geometry, topology, and energetic population in each of those elements. Yeah, each interactive with that object specification would have the same considerations as the object specification for each one. Distortion thresholds, energetic overload leading to geometric compromise or composite continuity breakdown, shearing thresholds, which current frame you would have breach, shatter, stretch, snap, and radiographic influences generally affecting energetic population but may have extended effects in overload considerations, like nuclear destabilization, fission reactions. Anyway, posing the question, most people would assume the situation that the object in free fall was moving toward Earth, but what if it was toward the sun? In Krem-reliant populations, it is a failed consideration without full context and interactive specificity. The systems employed there make this a matter of fact for most considerations, and specialists designing further specification completely adhere to holistic approach. That makes these systems extremely durable. Incrementalism sets the span of consideration to a range of progression and envelops the whole consideration for that range into a frame. Functions are tuned to solve for a framed consideration or an accumulation of framed considerations to produce an aggregated solution to an inquiry. So, for every consideration, there are 3 stages: initial, differential, and final. An aggregate solution would accumulate finals given an initialization, an incremental span, and a range. Frames would generally be tuned to align with spans and ranges, thereby containing all things within that increment. This way, the whole system can be set to a standard periodical view of state, and it is possible to construct a view that contains frames having views in them. Essentially, this enables up to full system encapsulation in real time, consistent with a container or controller, depending on the specific solution set. Means you can take your whole system and pass it as a parameter, dude. The whole thing. Band processing. Band processing is the approach that specifies ranges of views which can be handled concurrently. Essentially, it defines a band capable of handling a range of holes in equivalent sizing and graduates the handling of all views sized in that particular band. The approach is application agnostic, thus allowing concurrent segmentation of processing according to the scale in which the band is defined. An apt analogy is questioning how many bits are in your byte. Band processing would functionally accept all groupings of them, each according to its band, in the same concurrent feed. The end effect is stable processing for each successive layer, either graduated or minute, although the tendency is to raise the band stack once a stable basis is defined in a durable system. In other words, if you already got it and it works, you just build. Yeah? Foundations, yeah? Okay. Basic mathematical functions. Consistent with these approaches, these are a few approaches to regular issues one would find in most systematic analysis. Addition. Addition is an inherently ascensionate concern. No duh, right? Therefore, you would start with the most fundamental band and work upward. To evaluate the basic addition consideration, 9135467 correction 54321 45822 13217 43518 correction 08012 67771 14258 66678 28881 97981 83891 95970 30609 10120 15161 17210 283452426 99966 crams plus the same thing. you'd annotate the whole consideration before evaluation as accumulate function having two elements, each that specification of Krem with a division. Yeah. So post-evaluation, if expressed as initialization differential final, otherwise the functional return would be valued only at the third column. So generally, if you were going to get a return off that accumulation function right here, it would only consist of this third column, because that's the solution, man. That's the solution set. If you have positive Krem these values, positive Krem these values, you obtain positive Krem resultant set from addition, these values. Noting that band processing would generally consist of only 10 subranges, so the top value, 1F11, would be graduated to the next band. So in other words, in a good system that's capable, once it hit that top limit, it would kick that up to the next band for processing, but it would be a composite with everything that this band took care of also. Okay, subtraction. Subtraction in Krem is also handled as accumulation with the consideration to whether the figure group is ascensionate or descensionate. All figure groups are signed, so you technically wouldn't subtract, you'd accumulate. And the sign, ascensionate, positive, or descensionate, negative, would indicate the interaction set of the function would use in the accumulation. If the two figure groups are evenly ascensionate and descensionate, the net is, of course, nothing. Remember, in Krem, the fundamental or the numerical consideration is all natural numbers, which may act similar to integers with additional precision depending on the scale. The general handling of precision, that portion of the value between 0 and 1, is to adjust the basic whole unit of measure applicable to the situation. Generally, in Krem systems, the application of values between 0 and 1 is a reductive scalar coefficient to a whole, such as in proportionality adjustment. In such considerations, the whole situation is often evaluated in the scalar adjustment applied last. Since Krem systems tend to evaluate to only keeping whole functional results, the precision in a final evaluation is usually trimmed off rather than rounded. It is more accurate handling with real things. Prepended to the differential, you'd evaluate the relationship between the two of opposing signs. If the first and second figure groups are respectively negative descensionate and positive ascensionate, or positive ascensionate and negative descensionate, then you'd compare the absolute value of each and begin the accumulation with the greater first, then subtract the value group 2 from value group 1. The overall sign after evaluation is the original one on the greater absolute value prior to using the absolute value for comparison. If both figure groups are, and we're going to do that in a minute, so maybe it'll make more sense. If both figure groups are negative descensionate, negative or descensionate, just descensionate, then you'd add the absolute value of both and keep the sign. In other words, a negative minus a negative is a further negative, yeah. Like addition, you'd start from the lowest order and work upward. The difference for subtraction is that if the second value in the comparison doesn't satisfy the first band, the next highest order hands down a value of 1 in its band to complete the computation. This is a reliable approach since the operation is always ordered absolute value of the greater minus the absolute value of the lesser, then taking the sign of the greater for the final figure group. So to evaluate the basic subtraction consideration, said that number a few times now, minus 841264567237751 99921654731899178972589314896217987255866 3 Krems. You would annotate the whole consideration before E evaluation in the order it's received. So you would have your functional call with element 1, element 2. Now, since the absolute value, though, of element 2 is greater than element 1, and you can easily ascertain that visually in Krem, you don't have to sit there counting digits, man. You can just look at it and know immediately. Okay? Anyway, that would be functionally reordered for the greater absolute value first. In this case, it is the dissentient one, negative, so that's the sign that's going to be kept in the final evaluation. Other than that, we forget about that crap and we just take a look at the absolute value of the two and take the difference of those in the functional computation, man. So post-evaluation, if expressed as initialization differential final, otherwise the functional return would be valued only at the third column, the sign of the first value is carried. So what I was saying up here, the sign of the first value is carried. So first value carried. Also, this has a whole tier above this one, a whole 10th power factor scalar in value above what is being subtracted, man. So technically negative, and you're bumping it up, but it's still negative. So not quite. Anyway, good luck getting that done in a spreadsheet, man, and getting an actual total. A spreadsheet is going to clip this entire series, if you are lucky, maybe there, and it's going to dump the rest of those digits, and it's not going to tell you what happened, man. It's not even going to do it. It's not even going to try at all. This number system inherently does that because it cares about precision, and it doesn't do that crap like scientific notation does. The difference between this and scientific notation is this is actually accurate, man. So for multiplication is approached as a two-stage function. The base digitization is multiplied and the overflow is accumulated. If either figure group has a dissentient negative sign, the whole resultant final is dissentient. If both figure groups have dissentient negative signs, the whole resultant figure group is assentient. A negative times a negative is a positive, yeah. You remember your calculus teacher like preaching that at you? A negative times a negative is a positive. You forgot your sign. Yeah. You were in that class with me. You remember that shit. Should make you feel wonderful for that. You just forgot how to add, didn't you? While she gets out her slide rule and smokes you on how fast you can integrate, you know? But anyway, yeah, that always cracked me up. If both figure groups, blah, 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 it's positive. Negative times a negative is positive. Of course. I love how I spelled course there. Shit, dude. Anyway, of course, I'll fix it later. This is just a copy note. But anyway, both figure groups, if assentient positive, yield an assentient positive result. Positive times a positive is positive. For the computation, the sign is ignored because it's factored out definitively by the Krem standard articulation. So, if either figure group has a dissentient, so if you end up with a positive times a negative or a negative times a positive, it's negative, yeah? And a negative times a negative is a positive. And if it's a positive times a positive, it's positive. But who cares, because you don't care about the sign until it's over. It's multiplication, man. Yeah? Worry about that later. Factor it out. It's faster. Anyway, as in the subtraction function... Oh, crap, I misspelled function, too. We'll order the figure groups by greatest absolute value and carry the sign if it's eitherwise negative. For each number, the first figure group would be elementally by the 10th power factor scalar count multiplied by the second, yielding an accumulation set for each row, yielding a distinct intermediate set. Having completed all accumulation arguments for the whole set, each is tabulated iteratively. So, to evaluate the basic multiplication consideration using the same values as before, noting the unit is dropped on the scalar, Krem systems avoid stacking unit values in favor of geometric or other basic definition, different than how we do it here. In other words, you don't have x Krem times y Krem is xy Krem squared. That's dumb. You give an actual definition to the thing that which you are considering instead of some generic representation that doesn't really describe it, man. Okay? That's what that means. Different than how we do it here. Also note the annotation of a scalar is an unrepresented numerical. Here's an example of a unit agnostic numerical annotation in Krem, usually used for scalar applications. So if it's Krem annotation or Krem notation, but it's not in Krems, yeah? Like it doesn't have a specific distance value additional, it's a scalar, yeah? Or a coefficient, or however the hell you want to use it. It's a signed integer, man. You know. Okay. Onward to consider a basic multiplication problem. Yeah, I said that number before times. Yeah, I said that number before too. You'd annotate the whole consideration before evaluation. But this one's also negative. Yeah. Okay, so you'd annotate the whole consideration before evaluation. You would multiply element 1 times element 2. This carries the unit with it, and so that distributes, of course, right? And so does the dominant sign, yeah? In this case, since it's multiplication, negative times a positive would be negative. So you would have negative Krem, and the result of the multiplication of these two stacks, yeah? So, in order to do that, though, and I definitely screwed up the keying in here somewhere, just to let you know ahead of time, because I keyed all this in, dude. And sometimes you make mistakes, especially when it's in a text editor with no syntax checking, man. With this kind of crap. Anyway, those two arguments in multiplier functionally reordered. You put the greatest absolute value first, yeah? Reasons for that, yeah? So, it's easier multiplication, that's why. So, you multiply same two sets, right? And then the multiplication function would commence as a two-stage procedure. First, the multiplication arithmetic series is done to achieve a tabulation set. When multiplying elements to 10th power factor scalars are added for corresponding rows, and each figure group is multiplied in this way. The consideration is, for example, each element. So if you were to take that top level element there, donk, and begin at ones, right there, okay, that grouping, with no additional stepping, that would look something like this, yeah? So if you were to take this multiplication consideration and do it next, okay, and is approached as a 10, so this consideration is and is approached as a 10-based scaled breakdown of the scalar value. This is used to build a preliminary accumulation set for the current figure group element, and the scalar's 10th power factor scalar indicator is factored out and withheld until tabulation. Okay. That's talking about that right there. Yeah? You factor it out of the whole consideration, and you just worry about that, and you just worry about that. Now, worrying about that and that, you have to multiply each place value times this whole thing. Okay? And this is just basic multiplication, right, man? And then you add all of the resultants up from that. And that's what this is doing. So you peel off the 8, you multiply it by the second factor. You take the 4, you peel it off, you multiply it by the second factor, and you retain its placement value, factoring out its 10th power factor scalar, because you don't care about that. You're looking at a band. Bonk. This is band processing in action right here, dude. So each digit, man, you take, you place, you multiply, which evaluates to these resultant figures, okay? Still with the 10th power factor scalar 11 scale factored out, man, and it's distributive, of course. So, and then that accumulation evaluates and yields to a set again after applying the distributed 10th power factor scalar and adding all of these together. And so you get a neat and tidy resultant that with an F12 and an F11 10th power factor scalar in that neat little band right there, resulting from this multiplication right here. Yeah? Check me, man. Anyway, this is done for each increment of 10th power factor scalar in each figure group. So if you were to do it for the whole consideration as defined in the initial consideration, you would break it down by each band. Yeah? But you still have to multiply that band times the whole second factor. Okay? And each one of those is an element. So this multiply function is considering these two elements and is accumulated with this multiplication function considering the next two elements, is accumulated with this multiplication function considering the next two. So we're stepping down by band, yeah? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and then you're in the 1 set, the base set, first 10 digits of the number. How many things do you use 10 digits for, man? Astrophysicists do. But anyway, they'll get to play with it a lot. But anyway, which yields the accumulation set. The sign and unit of measure are distributive, as can be expected. That's talking about that. Okay. So after you do the multiplication and you get your sets resultant of the most internally nested multiplication functions with their two elements, you end up with an accumulation set from that. Okay? And that accumulation set is the addition of all of those elements. But notice the way that multiplication pans out is you have a carryover each element to the next. So this kind of stacks up and folds in. It compresses. So these have to be combined. They have to be accumulated, man, because they're of the same order of magnitude. Yeah? And so you have to accumulate that entire stack. All right? So you do. And then, that's for each band, dude. So this is just the F11 band. That's just the result of that. These two elements, yeah, yield in multiplication this set for accumulation here, yeah, powered at the 10th power, the 11th 10th power factor scalar. Anyway, so you have the 11th of those, the 10th, the 9th, the 8th, the 7th, the 6th, and this is distributed back in on whatever this evaluates to also, man. Oh yeah. Okay, so, and then you have 5, 4, 3, 2, 1. Yeah. This looks like a lot, but dude, to a system that does band processing, bonk, they can shit these out all day long, man. Fast. Massive calculations, dude. Very fast. Much faster than what digital capability has now. That's a steep claim. Well, it's true. Anyway, F1, and then you've got your ones here. So your last set. As a quick aside, if you were to tabulate this type of accumulation in a spreadsheet, it would look something like the following. Vertical descending by power and summed up at the right. You would carry the 11th plus highest digit upward to the next tier and add to the rightmost place if there is any overflow. Due to space limitations, we'll only look at the first 5 power tiers. So in other words, you stack them up, each one of those, right? So this is no additional, right? And then this is 1, and then 2, and then 3, and 4, and 5, yeah? So you sum these out to the right, and you end up with this. But what do you have here, man? By the Krem definition, you only work with 10 digits at a time per tier, man. And so these are overflow. What do you do with that? You take that 1 and you add it to that 1's place, because that is actually technically in alignment with that if you were to stretch it out. And so that would become a 9, and then this 1 would carry up and it would be in the 1's place on the next higher tier, yeah? Or additional to it. Or whatever the figure is here, folding upward, because it's addition, man. So the tabulation reduces as follows. You would have then accumulate, and then each element getting simplified here. So you would have each band distributive F11 to the functional set, and they all kind of look the same, except you have the distributive power here that folds onto these, man. And I did make a keying error somewhere into this crap because I manually keyed all of this shit, and I made a mistake on 3 digits somehow. I fucked up. But anyway, fucked up has a new meaning now. So F8, F7, almost an insignificant thing. Anyway, F6, F5, F4, F3, F2, F1, and 1's place, yeah? Or base set. So next, we'll go ahead and redistribute the factored value for each element's 10th power factor scalar. So we took that was on the end, bunk, and you distribute it. Multiplication, yeah? So with power factor scalars, remember when you multiply this, F1 times F1 That is f1 plus 1. So it would be f2. Because it's additive of powers, dude. It's multiplication, man. Additive, dude. Okay, if you add powers, okay, if you have two numbers and you can combine, and the coefficients are combinable, they're in the same, you can combine them. Anyway, and you have powers on each, when you multiply those together, you add the powers, man. You multiply the base, you add the power. All right, so same thing applies here. So next we'll go ahead and redistribute the factor value to the power factor scalar. So what we're doing there is we're taking that F11 that was outside here and distributing it up the tier. So it's basically F11 plus every damn thing that was there, dude. Okay? And we do that for each one. So F11, F10, F9, F8, F7, F6, F5, F4, F3, F2, F1, fucking A. Okay? Now, we'll line up the 10th power factor scalars and tabulate the whole set left to right, carrying the overflows up a tier. The final result, I screwed up right here, man. I don't know how I did that. The process is correct. I just have butterfingers somewhere, and I'm too lazy to go find it right now. Yeah? Okay. So, this is what the final number looks like, dude. Okay? This is the actual result of that function. So, if you were to use a large number calculator here and do this math, this is what the hell that would spit out at you, man, except for the offset on the keying error. Is that easier to understand, or is that? Come on, nerds, man. This has 230 digits in it, man. And I know that just by looking at it, dude. 22 times 10 plus 10. How long would that take you to count these? And if you weren't using a special calculator, would you even know? Beyond, like, the first 10, what the hell else even happened? Or would it just assume that you didn't need to know because science? Division. Okay, so first of all, okay, compare the two just real quick. You have the same figure. This is the standard classical representation of thousand spacings, comma, yeah? This is more similar to Krem notation if you were to apply that to a decimal like we use instead of the dumb way we do it. Which one are you going to be able to count all those digits with better, dude? And why the hell would you do that when you can do that? And it supports integration of units very tidily. Very neatly, dude. No ambiguity whatsoever because it's fully contained, man. Anyway, division as a function, mathematical. In Krem, division as a mathematical concept is not used. Uh-oh. Why? Research the algorithmic application of division and how you would computationally perform division at this scale, and then come get me, because to get the right answer, it takes a lot. Multiplication is the way to go. Anyway, so in Krem, we don't use division, we use allocation, okay? So instead, the principle of affirmative allocation is used. In the case of proportionality requirement, differential considerations are applied in consideration of one relationship to another, which may include figure groups having precision. So you may ask, well, isn't multiplying by a decimal the same as dividing if it's like 0 point and then you're multiplying by it? They taught you that in math, but the answer is no. And the answer in that, ask a dude named Newton what you have to do to actually get there, dude. Go figure it out. I'm not going to tell you. Anyway, this is a different paradigm and way of thinking than what is customary on Earth, but consider the foundational design implications. In Krem, the permanent approach is that of construction, ascent, accumulation, incrementalism, and functionally meeting requirements of those endeavors. You consider what to do with what you have and consider the requirement of what is needed based on how many each whole requester has the need and how many objects of necessity are needed by each requester. Or has need of. It's supposed to be has need of. Anyway, whatever. I was in a hurry. Anyway, remember the primary consideration in Krem is holistic approach. Considering whole things, even in terms of their whole component parts, each also being a whole thing. This is naturally the way things exist in physicality, and it is naturally the approach to keep this consideration as a primary in a concern for how to design a computational and real functional handling system for all things in it. So you're not doing theoretical, you're doing real. This is a shift to real paradigm and not imagining. Okay? You actually do it instead of talking about it, yeah? I don't... The academics, that shit's hard, man. Anyway, so instead of using division, how would you solve a requirement for allocation? Allocation is a multiplicative approach to a base consideration of how many or how much of something you need at an incrementally accumulated rate. The functional solution set to address this concern is therefore either summation or multiplication, not division. Take tithing or tax as an example. If you are required to allocate and render 10% of your wage for these purposes, the affirmative handling for this is as handling an incremental rate. For every 10 base units you have need of considering, you can only produce a whole one in satisfaction of the requirement. This would be handled as a multiplicative rate and using precision as a concept algorithmically distinct from division. Yeah, if you don't believe that, go dig for a minute and then articulate an algorithmic solution to a division problem, specifically long division, and then you'll understand. I'm not talking about using the math function in a programming language. I'm talking about articulating the actual solution algorithmically. Then this will make sense. For example, your wage is cents, 0.00057,43125. The basic whole of the currency being the cent, not the dollar, which is $57,431.25. Then you'd compute this in Krem as follows. You use a multiply function. You would use, this is 10% because remember this is positive. Fulcrum, tens place, yeah? F1, that's the first level consideration below Fulcrum. This F1 is a 1 over F1 ratio, meaning this is shifted over, yeah? Okay, so element 1, multiply that times all those cents, yeah? Which evaluates to showing the overflow, accumulate positive cents, Fulcrum, all of that notice that this is short a digit. Yeah? How come? How come? Well, it has, according to this, it's because where you have 1 here, that's in the 10th place, okay? So it drops, it shifts that whole higher tier number over a 10th place, yeah? And if you express the whole thing below Fulcrum, it's got an overflow. You'll bump that up a tier. So that graduates to 5,000, or sorry, not 5,000, 00005, 74312, Fulcrum 5, F1. Because Krem does not use rounding, only whole values. The partial under the Fulcrum A is discarded for purposes of payment. In other words, that's not a whole cent, man. Anything below that Fulcrum is considered precision, meaning it's not a whole. You're either using it as a scalar or you're just kind of showing, you know, what you're going to trim off the pie and cook up as a crust with some cinnamon and sugar on it, dude. But, like, not as something you can make into an apple pie or whatever. This yields, so since the 4 zeros, 5, 7, blah, 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 5,743.12. This may seem odd to some who are used to rounding, but in Krem, you do not assume the gap next to the hole is magically bridged under any circumstances. In other words, you don't round up, man. Be like, oh, well, we can do that. Just adds numbers. Because science. They don't do that crap, dude. Anyway, so what about a matter of conversion or ratio? How would that be performed? Like the example above, you'd apply an affirmative precision scalar, which algorithmically is distinctly different from division. Division is very costly in terms of functional computing time and can be affirmatively avoided by design. The affirmative design pattern is to consider rates and base your functional approach on a standard of wholes consistent with incrementalism. As an example consistent with apportionment and incrementalism is a consideration of how many loaves of bread you need to stock your store chain. You would consider this as a supply rate issue. How many loaves of bread can you make per day? And what seems reasonable based on sales, man? Would you would consider prior sales of loaves of bread per day, but in a departure from computing the division, this would always and only be handled as a comparative differential. For each whole, there are comparative whole others. Precision scalars could be applied to the ratio, but that is done as a multiplication of both using the same scalar value in Krem system, mathematically equivalent to multiplying by 1 over 1, which is 1. Division is not used. In celestial considerations of scale, even including all things in a vast area, both large and small, it is prudent to computationally avoid division in favor of relationships, differentials, and applications of precision scalars. Functionally, there is a huge difference between computational costs, especially the larger the scale. The lowest overhead approach in large analog processing systems is to affirmatively address computational needs. So that's Krem System intro. So further applications of Krem, you can do any damn thing with it. But applications using Krem that people do is musical encoding, like playing a symphony with your body, dude. All the instruments at the same time, you can do that. Data compression, processing compression, any periodic analysis, high fidelity, real recording, experiential, analog-based, functionally intelligent constructions of all kinds. And that's about it on Krem, dude. I hope that meant something to you. It's interesting to work on, man, and I just thought I would let you guys know like what we're kind of doing. So that's what we're doing. I hope y'all have a good day. I don't know when the hell I'm gonna post anything again. I'm pretty busy with this stuff, dude. Because it's good. It's really good, actually. If you know how to apply this, even in speculative considerations, you know. But we'll have software plugins for this shit soon, and so your spreadsheet will be able to give you the right answer, dude. Anyway, that's about it. It's like 2 fucking hours of reading. And fuckity fuck. That totally means something completely different now, doesn't it? The smallest of the small. Fundamentally. Take it easy.